turned on. Okay, and let me share my screen first. Okay, I think you are able to see my screen now. So in this lecture, we will have the review, actually an overview about the surveying, some of the histories and the fundamental topics that we're going to cover in this class. Basically, in this lecture, we will learn the classifications about different type of the surveys and a very brief history about how the surveying technology is developed, and some of the basic measurements in the surveying, and those would be the fundamental measurements that we have to know to conduct some of the complicated project. First of all, for the surveying, we know that the surveying is some techniques to measure the directions, the distance, and to identify the locations, and also to estimate the area of the land. But when we consider the shape of the Earth, the Earth is not in the flat plane. Instead, it's in the ball. So if we want to conduct a survey on the Earth, we have to one of the intuitive assumptions is like we want to assume that the Earth is in the spheroid. With that, we will try to identify the locations of different at different locations on the Earth, actually on the surface of the Earth. So this figure shows some of the fundamental concepts that we defined for the Earth surface. If we consider this Earth as the ball and applying the plane to cut the ball, and if the plane cross the center point, which will be, I say, the center of the Earth, then the interaction between the plane and the surface of the Earth will be the great circle. And in addition, for the measurement of two locations, say point A and point B on the Earth, usually what are we going to measure is the line along the surface of the Earth. And if we go to see the great circle, that will be in the arc. If we stand at very high or even outside of the Earth, this will be an arc. And also there will be some of the straight line to connect these 2 points. And this straight line is defined as the chord. This would be the fundamental lines on the Earth. And we have to know that if the point A and point B are very far away to each other, then the distance between the chord and the arc will be very different. But this only happens for the very large scale surveying. If we only consider the small region, the situation will be different. So that's the first thing we have to know about the surveying on the Earth as a spheroid. And there are also some other concepts we will define for the Earth surface. First of all, we have to identify 2 points. One is the north point, the other one is the south point. If we connect these 2 points, that will be in the axis. We define them as the polar axis. And if you connect the north point and south point with any straight line from the surface of the Earth, you will get a meridian. And then we can go back to see the 2 points that we defined in the previous slides, so that there will be 2 points, point A and point B. They will fall under different meridians. And also, this one is actually applied for you to identify the the coordinates, or which will be the absolute location of these 2 points on the Earth. And if we want to go to see more details about the locations of these 2 points on the Earth, say that point A and point B, we can just cut this slice from the meridian and the polar axis. And you can see that there exists an angle between point A and point B. And this will be the angle with respect to the center of the Earth. It's also useful information for us to identify the absolute location of any points on the Earth. One, actually, for the location of any point on the Earth, we can use the GPS coordinates. That will be the longitude and latitude. The other way is using this kind of distance and the angles. So this will be the angle and the distance to the center of the Earth. With that, we are able to find out the exact location of any point on the Earth. And another thing we have to consider is the equator, which will be the longest circle around the Earth. And usually the equator will cut to the center points of the meridian and go through the center of the Earth. So that's one type of the classification for the surveying on the Earth. The other way for us to do the classification is consider a more realistic shape of the Earth. The spheroid is some of the ideal consideration. We ignore the difference in the radius in the north and the south direction, and also the east and west direction. But in reality, if you go to check the radius of the Earth at different locations, you can find that they are not exactly the same. It's more realistic for us to assume that the surface of the Earth is ellipsoid. So the radius at different locations are different, even though the difference is not very huge. And another thing we need to think about is ideally, we can assume that the Earth's surface is quite smooth, but you know that in reality, it is not true. We have some hills which were above the sea level, and also have some location which will be much lower than the sea level. And this will indicate that the surface of the Earth is irregular. And sometimes we're gonna need to use this some points in this in the actual surface of the Earth, and apply this reference point to do the measurement. And with that kind of definition, we will define the surveying based on the actually we define it as the geodetic surveying, and this will use the true location on the surface of the Earth. And so there will be more definitions about how we're going to use the surface of the Earth to do the surveying. And the issue is a little bit different when we are considering a small region surveying. For example, if we only want to do some surveying in Hamilton area, then probably you don't need to think about the curvature of the Earth, which is too large for your small area survey. In that sense, we can just consider the Earth as a plane. So with this kind of definitions, when we consider the shape, we can just classify the surveying in two types. One is based on the true shape of the Earth's surface, and we call it as the geodetic surveying. And you can use the actual shape of the Earth, either the spheroid or ellipsoid. And this one is very useful for us to identify the location of any point on the Earth, which will be the GPS information. And the other way for us to do the survey on the Earth is called the plane survey. So we will ignore the curvature of the Earth at any location and assume that the surface of the Earth is in a plane. And the elevation at the different locations of the plane will be the same. And usually this kind of usually the elevation of the plane will be defined as the mean elevation in that area. And if we consider any 2 points in the plane and then draw a line to cross these 2 points, and this line will be in a straight line, it's not an arc. So that's the two difference for us to conduct the geodetic survey and the plane survey. And in addition, based on the functions or the objectives of the surveying, we can define 7 types of the surveying. The first one is called the photogrammetry surveying, and this one is usually applied to map the surface of the Earth. We're going to use different type of the technologies like the cameras, radar lidar, carried under the airplanes or satellites to map the surface conditions of the Earth at different areas. And this one is usually, if you go to check the Google Earth, that will be quite similar to the result from the photogrammetry surveying. And the second type of the surveying is called the boundary surveying, and this one is usually applied to identify the boundaries of the land, or it will be applied to establish the property corners, which would be the critical points, and calculate the areas of one land. So basically, at most of the time, you just need to specify the boundaries and those angles and do the calculation for the area. And the third one is called the control surveying. With that one, we will first identify some of the reference points, and then use these points to establish the network of the horizontal and vertical monuments, which will have the true value of the location and also their elevations. And then we will try to find out the measurement, identify location and elevations and distance or some other points to those reference points. And this is called the control surveying. And the first one is called the engineering surveying. The engineering surveying will provide the points and elevations for the building, which would be the something that is not from the nature. And we're going to need to use this kind of surveying to conduct some of the civil engineering projects, such as the some of the actual buildings, residential buildings, or it could be some of the bridges or the highway or the local roads. And the fifth one is called the topographic surveying. It's applied to collect the data and prepare the map to show the locations of the nature man-made features and elevations of the points on the ground for multiple uses. And this is especially important for the generation of the maps, and also it could be very useful for the civil engineers and especially transporting engineers to build the roads at some of the rural areas. And the sixth one is called the route surveying, which is one of the major topics we're going to cover in this class. And in this type of surveying, we will create topographic and other type of surveys for long and narrow project, which means the roads with there could be the highways, it could be the railways. And also sometimes we need to identify the shape and curvature and the distance for the pipelines and some of the transmission lines. Especially for this kind of the projects, you may need to go to some of the very rural areas. So you need to lay out these pipelines to cross the some of the mountains or even enter the water. And the last one is called the hydrographic surveying, and this one is majorly applied to identify the shorelines and the borders of the for some of the water areas. So we want to use these kind of surveying techniques to identify the shape of the bottom for the lake and also identify the boundaries of the lakes. So those would be the 7 types of the common surveys which will be applied in civil engineering. And regarding to the development of the surveying technologies, actually our society has started to use the surveying technology for a long time. It can start in Egypt about 2,500 years ago. So about 1400 BC, in Egypt, due to the annual flood, the land which was measured in the previous year will usually be washed away. So they need to do some measurement about the boundaries of the land every year, and the way for them to conduct this kind of measurement or for them to divide the land, it's using some of the ropes. They have some specific person called the rope stretchers, and this would be the ancient surveyors. So they will relocate or re-identify the boundaries of the lanes for each person, and usually they will try to have the rope and apply some of the knots on the rope with the same distance, and then using the knots and the rope to measure the distance of the land boundaries. And this one we suspect that this one will also be applied for them to develop the Egyptian monuments. So that's the very old technology. And later on in 160 BC in Greece, they developed the several tools to conduct very precise surveying. Usually this kind of tools is applied to also apply for the land division. So the first piece of the surveying equipment is called the diopter, and there will be 3 types of the diopters that you can see in this slides. For most of them, they will be actually applied to identify find out the straight line of the land boundaries, and then they also use these tools and develop a standardized procedure to complete this land division work. If you are interested about the more details about the diopters, you can actually do some Google about these tools, and there will be some interesting introductions about each piece of the instrument. And in Rome, and there will be the survey is actually being further developed, and they will even create a science to develop the roles in Rome, and also they will still be applied for the land division. So they actually have some of the professional organizations to for the surveyors, and they develop some of the new instruments. This one is called the first one is called the GROMA, which were used in a cross instrument to determine the lines with the right angles, so that they can find out and divide the boundary into 4 pieces. And the second one is called the labeller, which is one kind of the A frame with the plumb bob, and it's usually applied to for leveling purpose to make sure that the multiple points will be placed under the same elevation. And the last piece is called the core base. It's also applied for the leveling purpose, and this one will have the 20-inch straight edge, and it will have some oils applied on the top of the surface, and based on the movements of the oil, they can try to find out 2 points with the same elevation. So that's for the Empire of the Rome, and in the Middle Ages, this land division technology is continuously applied in Europe, and they developed a new tool called the quadrant, and this is quite similar to what we are using in nowadays. So they will have the quadrant will have the right angle for 90 degrees, and then they will divide this one into smaller values. With that, you can identify where you can identify the angles and directions accurately. And when close to modern ages, we will have the like in 18th and 19th centuries, the need of the mapping and making the land claim caused an extensive development of the surveying tools and also the surveying technologies. While in 1785, the US began extensive surveying about the public land across the whole country. They will even have the marks for every square mile in the whole country. And at that time, there are only 30 states in US, but they are all measured appropriately with this 1 mile square sectors. And later on in 1807, the US Geological Surveying was founded to establish a very accurate control points. And this kind of control points is the one that I just mentioned about the control surveying. So they will have develop multiple reference points in the whole country and then do the mapping based on these reference points. Later in 20th centuries and to now, we will have a lot of advanced technologies, and for now we will even have the license for the surveyors, and there will be some educational requirements for the license. So for the surveyors in nowadays, they need to know how to use some of the electronically distance measurement tools, some of the positioning tools with the GPS system, some of the construction machine control tools, or even with the LiDAR system. And these kind of tools will be applied a lot to rebuild the infrastructures and the geographic information system. With that, you can find out this one will be very helpful for the current navigation system and also different of the construction work. And actually, even nowadays, we still need a lot of licensed professionals in surveying area. So it's a very good career for you to gain the skill in surveying. And here I have a very short video which can hopefully can be played. Let me try to see whether whether it can be played or not. Let me just a moment. Let me Okay, share screen. So let me know if you can get any voice from this video. Okay. So the video just shows you the brief review about the development of the survey, which is you can see some of the fancy technology at the current days. And actually, we're going to use some of the tools in our lab experiment. You will have the experience to use those tools to conduct the similar task as shown in the video. And of course, you will have some of the freedom to do more complicated work in the field experiment if you think that you can make your work done more efficiently and your result more accurately. I guess that's the very brief introduction about the surveying, the histories, and also the different type of the surveys. Do you have any questions for now? I know some of you may not have some issue to go to watch the video. You can actually watch it again after the class. The link is actually shown in the notes, so you can always check it later. Okay. So now let's go to check some of the basic concepts that we have to use in this class. Those are actually very fundamental definitions for us to conduct all different type of the surveying task. So those concepts will include the horizontal plane and also the horizontal line, the vertical plane and the vertical line and the angles. And also we have to know what is the zenith angle, what is the vertical distance, the elevation, and what's the grade or gradient. So let's first go to check the horizontal plane. Basically, for the horizontal plane, it's actually defined based on the shape of the Earth. At most of the time, if you go to check your surrounding environment, you can find that your the ground is if the ground is flat, you can consider this as a horizontal plane. And if we go to see the Earth as a ball, then you have to consider the horizontal plane would be the plane that will be tangent to the surface of the Earth. So the most critical concept is like this one should be tangent to surface. And this indicates that there will be a lot of horizontal planes for if we are specify one location, there will be one horizontal plane. And if we consider multiple points on the Earth, there will be multiple horizontal plane. The figure here shows the one horizontal plane with respect to the reference point. See, this is the point A. And this is called the horizontal plane to the point A. And for any line on this horizontal plane is defined as the horizontal line. So we can see that the x-axis is in the horizontal line, y-axis is also in the horizontal line. But for any other point lines in this plane, say any points B and C, if we do draw on the line, it's also in the horizontal line. And for the point A, we just call it as the standing point. And this is the most critical point for you to define the horizontal plane on the Earth. So that's the definition of the horizontal plane and horizontal line. And the one that is similar to the horizontal plane, it's called the vertical plane, and also the vertical line. Still, we need a reference point. For the vertical plane, if we consider the reference point is the point that you are standing on the Earth, the vertical plane would be in a straight line from your current point to the center of the Earth. Say that the point O, the center of the Earth. This would be the center of Earth. And for with the defined vertical line, for any plane which will which will include the vertical line, they will be defined as the vertical plane. So this indicates that for one reference point on the Earth, there's say one point A, there will be one vertical line. And there will be infinite vertical plane. And there will be another question. If I provide with you about one reference point, how many horizontal plane can you find? Does anyone have the ideas about how many horizontal plane can you find?
Would it be only one because there's only one tangent?
Yes, that would be right. Yeah, so we will only have one horizontal plane, but we will have infinite number of the horizontal lines. So those will be lines along the horizontal plane. So that will be the two fundamental concepts for us to do the measurement in surveying. Because for the surveying, one of the most important job is identify the boundaries, and those boundaries will be the lines. It could be a straight line and also some of the curves. And the next thing which will be very tricky is like still let's consider you have a reference point which would be point A, and with the reference point A, you can find out the horizontal plane, which will be the axis defined as east and the north plane. And this is the horizontal plane, the east and north plane at the reference point A. And you can also find out in the vertical line. So this is the vertical line. And you know that you only have one vertical line and one horizontal plane. And for the vertical line, it should go through the reference point. That will be reference point A. And on the Earth, the vertical line is also called the zenith axis. And with the definition of the zenith and the horizontal plane, the east and north plane, we can then identify the angles, including the vertical angle and the zenith angle. So assuming that you are looking at one direction, it could be any direction. It could be direction on the plane. You can watch at the one point in the horizontal plane. You can also watch at the point in the air or one point under the ground. Any point that will be fine. Assuming that in this example, we consider that you are trying to look at the sun, and there will be a direction from A to S. And then based on this one, we can define the vertical angle and zenith angle. The vertical angle is defined as the angle between the line from A to S, say that AS, versus the line from A to S prime. A to S prime. S prime would be the projected line, the projected point of S, which would be a projected point to the horizontal plane. So S is the on the EM plane. And then the angle between AS and AS prime, which would be the alpha here. This one is defined as the vertical angle. And then for the Zener's angle, it's defined as the angle between the line AS and the Zener's line. Say we define this one as AZ. And this would be the Zener's angle. And this would be two very important concept for you to identify the directions at any point on the Earth. It could be on the surface of the Earth or any other locations above or below the Earth's surface. And with this kind of definition, I would like to show you one example about how to calculate the Zener's angle and the vertical angle. Assuming that we have the horizontal line, I just make it simple. We have the horizontal line and also Zener's, and these are Zener's axis. And now let's consider a direction from A to S. And in this case, we will have two angles, theta and alpha. Well, for these two angles, what is the which one is the Zener's angle? Which one is the vertical angle?
Theta is Zener's angle?
Theta is the Zener's angle, yes. And alpha is the vertical angle. So always remember that the Zener's angle is the angle between the line that you are trying to measure with respect to the Zener's axis. And the vertical angle is the angle between the line you're going to observe and the horizontal line. Horizontal line applied in the horizontal plane. Okay, and now if I tell you that theta equal to 52 degree 15 minutes, what is the value of alpha? And do you know how to find out this? How to find out the value of alpha? Probably I can show you how to do this calculation first, and then you can try the other example. So for the calculation of alpha, you can see that the Zener's axis is actually perpendicular to the horizontal axis, and that indicates that the angle here is 90 degree. So alpha will be 90 degree minus theta. And if we go to find out the value 90 degree minus 52 degree 15 minutes, and we know that 1 degree, which means it will be better. 1 degree will be 60 minutes, and 1 minute will be 60 seconds. So that's the conversion between the degree, minutes, and seconds for the angles. So to do this calculation, I'll just show you the details about the calculation. So the 90 degree basically is 89 degree 60 minutes minus 52 degree 15 minutes. So we will have 89 minus 52 degree and 60 minus 15 minutes, which will give you the result as 37 degree 45 minutes. So that's the way for you to find out the value of alpha. So now I'll give you another question. Say that the theta equal to 43 degree 10 minutes and 30 seconds. How can you find out the value of alpha? Can anyone provide the solution for this? Okay, so I actually saw some questions in the meeting chat, and there will be some confusions about minutes and seconds. I thought you know the definition. Actually, in the angles, for the measurement of the angle, minutes and seconds will be the kind of the unit for the angle, and different from the measurement about the length. Like for the angles, it increase at every 60 units. So 60 seconds will be 1 minute, and 60 minutes will be 1 degree. And 1 revolution will be 160 degree. And I saw some of the solution, and that solution would be correct. So basically, for the calculation, alpha, so I saw the answer like 46 degree 49 minutes and 30 seconds. That's the right answer. It's a great job. So we still have 90 degree minus theta, and for at this time we want to get both minutes and seconds for the calculation. So what we have is like we have 89 degree, and we also have 30 minutes, but we also want to have some of the units in the seconds. So we will do another conversion. So 89 minutes and 60 seconds minus the value we get for the theta, 33 degree 10 minutes and 30 seconds. So if we do the calculation for each part, the result will be 46 degree and 49 minutes and 30 seconds. So this would be the way for you to find out the conversion between the zenith angle and the vertical angle. And well, as the example, I should put something here, but I put in the first one. And also we have something about the vertical distance and the elevation, and also the gradient, but I don't think we have enough time today. So I will just pause here. We will do more discussion about the basic concept in the next lecture. So for now, I would like to have save some time for the questions. Do you have any questions about this calculation and the concepts? You can raise your hand, or you can leave your questions in the meeting chat. Okay, Manon, I'm not quite sure whether I pronounced it right.
Hi, Professor. I was still a bit confused about the degrees in minutes and seconds. Would you mind re-explaining that, please?
So yes, sure. So let's consider the whole revolution. So you know that for the whole revolution, that will be 360 degree, right? That's what we defined. And for each degree, it will be 60 minutes. So here, minutes, don't consider the minutes as the time unit. It's an angle measurement. So say that if this angle is of course, this is not a 1 degree. If this is 1 degree, we will divide them into 60 units, and each one will be 1 minute. And similarly, for 1 minute, if this is a 1 minute, you can divide them into 60 units evenly, and each one will be 1 second. So here, minute and seconds are the units for the angle, not for the time. Okay, and another question that I got is about how to get the 90 degree to 89 and 50, 89 degree, 59 minutes and 60 seconds. So 90 degree will be 89 degree plus 1 degree, and 89 degree, one degree will be 60 minutes. And for 60 minutes, it can be 59 minutes plus 1 minute, and it can replace 1 minute with 60 seconds. So with that, it have 89 degree, 59 minutes, and 60 seconds. So that's the way for you to do the conversion. And Sony?
I had a question from the slides at the beginning. I don't understand how there was one vertical line and infinite vertical planes, but there's one horizontal plane and infinite horizontal lines. I don't understand the difference between them.
Yes. So if we consider, probably it will be easier for me to go to that. Let's just change it back to the get it back to the page. So for the horizontal plane, we are talking about 1 point. So for each reference point, there will be only 1 point on the Earth. And if we want to find out a tangent plane, you can only find out 1 tangent plane, which will cross the reference point. That's actually the definition of tangent. With the if one plane is tangent to another surface, it must only have 1 crossing point, which will be the reference point. In that sense, it means that we only have 1 horizontal plane. And for the horizontal line, actually any straight line in the horizontal plane is called the horizontal line. So you can draw infinite number of the lines in the horizontal plane. So you will have infinite number of the horizontal lines. So that's the horizontal plane and horizontal line. But for the vertical line, it might, I don't know how to draw it to make it more straightforward. Consider this is the Earth, and this is the point, the reference point A, and this is the center of the Earth. The vertical line is actually a line which will start from the center of the Earth and cross the reference point. And this would be the line, the vertical line, as connecting 2 points. So you will only have one line to crossing these 2 points. This indicates that if you are provided with 1 reference point, you will only have 1 vertical line. And if we go to see the geometry, some of the fundamental knowledge of geometry, you are provided with 1 line. You actually can draw infinite number of the plane, which will cross this line, as what you're going to show here. So you could have this orange plane. yellow plane, you can also have some other plane will cross this vertical line, and so you can draw infinite number of the planes. So that's the way for you to identify the vertical plane and the vertical line, and also the horizontal plane, horizontal line. So what we conclude is that for one reference point, we only have one vertical line and one horizontal plane, but we have infinite number of the vertical planes and infinite number of the horizontal lines.
And from the slide before, there was also the standing point. How does that relate to these?
The standing point is the point where you're gonna start your measurement, or you will set as the reference point for your measurement. So for this case, point A is the standing point, which would be the point A here. And in the previous one, you can consider this one as the, if we draw a line from the center here, this will be the vertical line. So A is always the standing point, which is the point on the surface of the Earth.
All right, thank you.
Okay, is there any other questions? Okay, if there are any other questions, I think that will be all today. I'm sorry that it takes longer time. And we will continue the discussion about the slides next week. I'll try to finish the introduction about the other concepts. And in the meanwhile, you can go back to review the slides, and also try to check the upcoming slides for the next week. And send me email if you have any questions about the course materials. We will not have any homework in this week, but for the next week you will have the tutorial session actually in the afternoon of Monday. So for those who attend the in-person activity, you can go to the room CNH 103. And for those who join the online, it will be broadcasted through the MS Teams, and also we will give you more instructions about how to access to the tutorial session later this week. There will be some trainings for the TA to use those tools, instruments in the classroom. Okay, I guess that's all today, and thank you very much for your attendance, and I will see you next week.